All right, in this video, I'm going to talk about decision trees and how they work. So this is actually part one of a four-part series. In this one, I'm going to talk about what is a decision tree. Part two, I'm going to talk about the data, how you get it ready to use to create the decision tree. And then in part three, I'm going to talk about the code, actually producing the tree with Python. And then in four, we're going to look at how you can use the model that you created and run some data against it. All right, and so let's get into it. Like, what is a decision tree and how does it work? So simply put, a decision tree is kind of like a flow chart. It's a type of supervised machine learning that makes predictions based on some data that is fed into it. And you get this flow chart that looks like a tree that are basically each stopping point in here is a question. Is your age less than 18? If yes, you go down here. Is your weight greater than 60? Here. The data set I'm going to use is based on a couple that I've came across on Kaggle.com that deal with heart disease. And so that is kind of the end result, whether you have heart disease or not, whether you're at risk for getting heart disease or not. And of course, it goes without saying that this is just for learning purposes. I wouldn't draw any conclusions. All right, so let's dig a little deeper here. So you have to have, your data set has to have an outcome column. Like I said, whether the person has heart disease or not. Now this is, I think the data set I got was an actual data set from a hospital somewhere of patients. And, so this is real data of a person did have heart disease or not. And there's a bunch of columns in here that are indicators like, did they smoke? What was their age? Are they overweight? What was the blood pressure? All that kind of thing. And so you have to, though, have an outcome column. And that's what really makes it supervised learning is there's a labeled outcome column that we use to train our data. And then we hope that the tree would be able to make predictions on new data that you give to it. And so that's kind of how that works. All right, so you can pause this video if you want to kind of read this in more detail, but the key takeaway from here is the advantages of a decision tree are it's simple to use. It actually is, it does a great job of visualizing what's going on. That's what I think a main reason a lot of people like decision trees. And they are used in a lot of settings. And so they have practical applications. And like I said, they do fall under supervised learning. All right, so the key part of putting together your decision tree is determining the order of the tree. Okay, and so to do that, you have to run some calculations. And when I say we're going to get a Python library called Skykit that's going to run this for us. It does this all in the background, but just at like a real high level, I'll just let you know that there's this calculation called the Gini calculation. There's other ones too, but the Gini is probably the most widely used one. That basically what that does is it looks at each column one by one, and like for instance, if we look at a smoker, and it looks, all right, how many people who said yes to smoking also end up having heart disease, and so if the Gini calculation would be the purest, the highest, if 100% of those people said ended up having heart disease, and then those who said no, 100% were no to heart disease. Actually, it doesn't even matter. Like if they said no and 100% had heart disease, that would be a pure node as well. But you get the gist. Like usually when you say no, there's a more common chance that you're not going to have heart disease. But anyway, and then so that calculation is run. It's if you want to dive deep into this, you can do a little Googling. And actually, if you want me to make a separate video, I'd be glad to. This is kind of what the formula looks like. But what happens then is, so you run that calculation for each of the columns, smoker, blood pressure, whatever. And the one that has the highest, the most pure Jenny, is the one that becomes the root. And then what you do is you actually run it. So you look at, all right, all the people who said yes to smoking. You look at that subset of people and how did they do in relation to the other columns. You just run the Gini all again, looking at the other columns. And if whatever one becomes the highest at that point becomes the next branch in the tree. And actually you can run smoker again, and that could even be a sub branch, which sounds odd, but sometimes it is the most impactful to do that. And yeah, so this is just kind of another visualization of what I was talking about. So this one, the root was age, and then it was determined for people over 30 that the most impactful next branch to look at was whether you're a smoker or not. And if you look over here, it was impactful. The most impactful column was, well, your weight. And so that's what's going on here. That's how that works. You just keep running those calculations till you end up with, depending on, I'll get into in a future video, you have a max depth that you're going to go. How many branches your tree is going to have. And once you reach that max depth, then you're done. And in that last branch, you actually have to make a decision. Is this person at risk for heart disease or not? So that's how that works. Hopefully that makes sense. If you have questions, let me know. Glad to go into more detail. But in the next video, I'm going to look at the data sets and how we can clean them and get them ready for using with our code. All right.